Oh, because uh, you, but maybe you were smiling and just can't tell because it's behind the mask. All right. I just wanted to quickly go over this one. I know the answer is out there, but you may have not had time to check it out. That's fine. Uh, so we have a fence being built, and it's a lattice, right? Like a lot of decks or whatever, they have a lattice around it, either to have like a vine grow on it or something, or for privacy. But we're told, so it's a partially labeled scenario. DB is 30 centimeters long. So this stretch right here is right there. Okay. And so the assumption is that this side will be the same as the other, right? Like you would not make something like this asymmetrical, right? It would be the same. So because they're telling you that this whole thing is 30, we know that this little stretch is 15 and this is 15 as well, because we're assuming that this is being cut in half here at this point. That's how you would build something like that, right? And and so you just have to kind of infer that, hey, if this is 30, this is 30 also, and that this length would be the same as this length here. So you can actually go ahead and say, mark these stretches the same as well. And therefore, all of these are 15. So that was the first assumption you could make. They also tell you that angle BAC is 60. So BAC, it's already labeled in there. And you could also say, you're like, hey, if 60 is across 15, then across this 15, you must have a 60 as well. And then you can actually translate that and say, okay, that's the same triangle upside down. So if these two are 60, these two are 60. And then you should say, hey, wait a minute. 60 and 60, what must the third angle be? 60, right? So this is 60 all around. So we have two equilateral triangles. Okay. So what's the measure of CDE? So you just go look uh, and just go CDE, and we can tell that it is 60 degrees. Right? So angle CDE is 60 degrees. What's the length of DE? So all of these are just answering based on my labeling, but I usually fill in as much as I can on my triangle and then just answer just by grabbing the number. So D to E, what must this be here from there to there? Well, it's equilateral, so all three are the same. So DE is equal to 15 centimeters as well. And now the trickiest part of all, maybe. If Nadine has a fence about 2 meters high, that's 200 centimeters, right? Because one meter has, oh, you can't see that. Sorry. If Nadine, right, has a 2 meter high fence that's 200 centimeters, how many sections will she need to build vertically? So they're basically saying, hey, if this is how high you want it, right? And so how many of these guys would you have to stack, right, to get to 200 centimeters? And why did I go centimeters? Because all the measurements up there are centimeters, right? So they're asking how many are you going to have to stack to make that happen, okay? So how would you do that? Well, let's go back to the top. This is what I'm going to do. I'm going to figure out this distance across. This is x, okay? And so I see a triangle here like this, and I can use cosine law to do that, okay? So let's go down here and label that. This is 15. This is 15. What's this angle here? 200 bucks if you get it right. No, I'm just kidding. It's 60? Who said 60? It's not 60. It's 120. If I had 200 bucks, you'd get it, but I don't have 200 bucks. So okay, this is where, see, you fall asleep and it's like, what? Uh, this is 60 here, right? This is a straight line, right? If this is 60, is along a straight line, then this must be 120, right? So it's this angle we're after. So let's go arrow. Oh my goodness, arrows. But you know, if you don't make the arrow, you're not going to make that connection later on when you review it, okay? So we have a SAS, right? We have an SAS scenario. We got the 120 from up there. So x squared is going to be 15 squared plus 15 squared. You should beat me to this. You should know how to do this by now. Actually, there's a bit of a problem here. If you do it in steps, this is going to give you a negative. So if you do this in steps, you will have some trouble doing this. And I'm going to recalculate this because I'm not sure where the key is that I gave you. And this is 675, which in turn turns into 25.98. We'll just leave it at that. 25.98, and this is in centimeters. So we know that one of these sections across is this tall. Height of one section. So then we have to say this. Are you ready for this? This is your proportional reasoning. If one section, if you can apply this to life, you can solve a lot of problems. If one section is 25.98 centimeters, I know I did it differently on my key. So then X number of sections will be needed for 200 centimeters, right? Because I need to know how many sections. Cross multiply and divide. This is 200 divided by 25.98 really. And that is 7.698. So how many sections are you going to buy? 7 or 8? 8, right? You want to have enough for sure. You know what? How you do this, it's not really, like if you find this, if you just went ahead and divided these two, that's fine with me. You don't have to set it up like this. But, right, you found, hey, one section is this, that's true, then, right, you just set it up like that. Now we're going to start. I'm going to give you a worksheet yet for more triangle stuff to practice, but this is it for today for triangles. I'm moving on now to four-sided quadrilaterals. Okay. All right, I'm going to stop this here.